So we're going to start off by defining what pressure is. Pressure can be defined as the force exerted by gas molecules within a given volume. So if we have in a container here, the circle, 3 gas molecules, they're going to exert a certain amount of force on the side of the container. If we have the same container again with more gas molecules within it, it's going to exert greater pressure or higher pressure. So the container on the right with more gas molecules has a higher pressure, and the container on the left with less gas molecules will have a lower pressure. When we talk about pressure, we usually put numbers to things, whether it's measured in millimeters of mercury, torr, or any number of different units to measure pressure. We're going to talk about the total pressure in terms of numbers. The container on the left has 3 gas molecules, so we're going to give it a total pressure of 3, while the container on the right has 10 gas molecules, so we're going to give it a pressure of 10. For now, we're going to leave units out of it. So in terms of what is a partial pressure, this is the portion of a total pressure exerted by the presence of a single gas molecule. So for example here, we have a container with 3 different types of gases. We have the orange gas, we have the green gas, and we have the yellow gas. All 3 gases contribute to force on the container walls, and it's going to have a total pressure of 10 because there's 10 gas molecules. But if we just want to look at the orange gas, its pressure due to the single orange gas is 5 because there's 5 gas molecules. For the green gas, there's 4 gas molecules, so its partial pressure is 4. And finally, for the yellow gas, there's only 1 of it, so its partial pressure is 1. So if we add up all the numbers, the orange gas being 5 molecules, the green gas having 4, and the yellow gas having 1, there's a total pressure of 10. Now let's use the example of the air that we breathe. So in the air we breathe, there's a mixture of gases. There's nitrogen, oxygen, and carbon dioxide, all present in different proportions. And they're each going to contribute to the total atmospheric pressure. We know that the total atmospheric pressure at sea level is about 760 millimeters of mercury. That's the total pressure. But we're going to find out the partial pressures due to each presence of a single gas. So what's the PO2, the pressure due to oxygen? What's the PN2, the pressure due to nitrogen? And what's the PCO2, the pressure due to carbon dioxide? So again, we have 3 gases in atmospheric air. We have nitrogen, oxygen, and carbon dioxide. Nitrogen makes up about 79% of atmospheric air, oxygen 20.93%, and carbon dioxide is present in a very small quantity as 0.03%. We can write all 3 of these gases in terms of percentage or as a fraction, 0.79, 0.2093, and 0.0003. This will come into play later when we start to do some calculations. So again, the partial pressure is the portion of the total pressure exerted by the presence of a single gas. So we can say that the total pressure in the atmosphere, so for example 760 millimeters of mercury at sea level, is due to the partial pressure of nitrogen plus the partial pressure of oxygen plus the partial pressure of carbon dioxide. We're going to now calculate each of these pressures. So we're going to take, to find out the partial pressure, the fraction, so the percentage of that gas that makes up the air, and multiply it by the total pressure. So for example, let's find out the partial pressure of nitrogen. If we take its fraction, which is 79%, and multiply it by the total atmospheric pressure at sea level, we're going to find out that the partial pressure of nitrogen is 600.6 millimeters of mercury. So that's its contribution to the total pressure. For oxygen, we're going to take its fraction, which is 0.2093, multiply it by total pressure, and we get about 159.1 millimeters of mercury. And finally, for carbon dioxide, we're going to take its fraction, 0.003, multiply it by total pressure, and get about 0.3 millimeters of mercury being its partial pressure. Now, if you add up all of these three partial pressures, so PN2 plus PO2 plus PCO2, you're going to get a total pressure of 760 millimeters of mercury, which is what total pressure is at sea level.